Right, in this video I'm going to run through the questions you'll need for quiz 7. There's a few 6 markers in here. The first one is on the core practical that you did last week. You're told you're reacting zinc with hydrochloric acid, and they want you to tell how you would do that, and they want you to change the concentration of hydrochloric acid. And just essentially explain how you would carry out that experiment. So when you're asked to devise a plan, okay, and describe how you do an experiment, these are the things you need to include. You need to tell me apparatus, that's just equipment, so what equipment did you use? What are you actually going to do with that equipment? How do you do the experiment? What results are you going to measure? And then the controls. When you go from one concentration of acid to the other, what do you keep the same to make sure the test is fair? There's a second part of this question that talks about the reaction being more exothermic. We haven't done that yet, so I'm going to ignore that part of the question, and we're just going to focus on the rest of it. Alright, so we're going to start off with the apparatus. What do you need to do? Okay, so I have written it out here. Alright, you're trying to react an acid with a metal. Acid is going to be in liquid form, so you're going to measure the volume out using a measuring cylinder. You don't need to give me a specific volume. You can even say measure amount of HCl using a measuring cylinder. You get the marks for that. And once you've measured out your hydrochloric acid, you're going to add it to a conical flask. So measuring cylinder, conical flask, that's an example of apparatus. Zinc is a metal, it's a solid, okay? To get the mass, to measure out the solid, you're going to get the mass of it. How much does it weigh? And you're going to do that using a mass balance. So measure the mass of zinc using a mass balance. So once you've measured them both out, you're going to add the zinc to the acid, okay? But because you're going to produce a gas and you don't want that gas to be able to escape, you're immediately going to put in your stopper. Your conical flask is going to be attached to a gas syringe, okay, and that gas syringe is going to allow us to record the volume of gas produced, say, every 30 seconds, or you can just say record the amount of gas produced over time. But that's you telling me what you're actually going to measure to record these results. So far I've hit apparatus because I've mentioned measuring cylinder, conical flask, gas syringe. I've hit what I'm going to do because I've described how I'm going to do it, and what I'm actually measuring here is I'm recording the volume of gas produced every 30 seconds, or the volume of gas produced over time. Once you've done this whole thing once for one concentration of acid, you need to do it again for another concentration of acid. So you don't need to describe it all again, just say repeat the experiment. This time you're going to use a more concentrated acid, but everything else has to stay the same. So if you weighed out 2 grams of zinc the first time round, you're going to use 2 grams of zinc the second time round. If you did it at room temperature the first time round, you'll do it at room temperature the second time round. The other thing you could say about the zinc, because it's a solid, you could say that the surface area has to stay the same. So if you use large pieces of zinc in the first reaction, you can't use, crush it up with a pestle and mortar in the second reaction. So everything other than the concentration of the acid has to stay the same, and that's going to be all 6 marks. The next question, we actually saw this in our quiz the other week. Why does the mixture turn cloudy? Quite a few of you got this wrong, okay? It turns cloudy because you're making a solid, and the reason it's actually 2 marks is you get 1 mark for saying you make a solid, and then a second mark for telling me what that solid is. So S stands for sulfur, so you're making sulfur, which is a solid. If you're making something that's a solid, how do you measure the rate? We did this last week in the practical. It's the disappearing cross method. Draw a cross on a tile, put the conical flask on top, time how long it takes for the cross to disappear. You have to mention time. A few of you didn't in your answers last week. Alright, so make sure you're mentioning time. The next one here, this was tricky. It says in the mark scheme that very few people got this right, okay? So you're using a 250 centimeters cubed measuring cylinder, and if you look here, you're only actually producing 60 centimeters cubed of gas, and they want you to give something that will more accurately measure the volume of gas produced, and they don't accept saying a gas syringe instead. Instead of using a 250 centimeters cubed one, they want you to use a 100 centimeters cubed one, okay? And the reason, if you had a 250 compared to a 100, okay, on the 250 the lines are quite far apart. On the 100 the lines are much closer together, and because they're closer together it's going to be easier to read it. If you're only making 60, you're always going to go for the most accurate measuring cylinder. There's no need to use this really big one, which isn't as accurate when you're only producing 60 centimeters cubed. So your reason 100 centimeters cubed measuring cylinder. And you wouldn't necessarily have to say 100, just say smaller than 250. If you say, as long as it's smaller than 250 and bigger than 60, you'll get the marks for this. So you could say a 75 centimeter cube measuring cylinder. So I'm going to say 100 centimeter cube measuring cylinder because there are more. They're called graduations. All of those little lines that you see on a measuring device are called graduations, and it just makes it more accurate. It's easier to read if those lines are closer together. Then it asks you to calculate the rate. So we know that rate is change divided by the time. The change here, if I look at my units, I want the change to be in centimeters cubed, and I want my time to be in seconds. All right, so in order to work out the change, you're gonna have to use your graph. It says it's 90 seconds, so you're gonna have to come down here. They've given you it in minutes, but 90 seconds will be a minute and a half. So that's 1 minute in between 0 and 2, and then in between 1 and 2, you're gonna get your 90 seconds. And then what you need to do is, now that I've located 90 seconds, you do this with a ruler. You need to go up to the graph, and then you need to go across. And that will tell you how much, so that will tell you the volume that is produced after 90 seconds. And then the volume is going to be my change, so that's 29 centimeters cubed, and the time is going to be, as we said, 90 seconds. And then you just do 29 divided by 90, which is going to work out around 0.3, and the units are already correct. Why could the measurements have been stopped at 9 minutes? All right, if we look here at 9 minutes, the graph is already totally flat. Okay, so you can say one of two things. You can say at 9 minutes the graph is already flat, so we know the reaction is stopped, there's no need to let it run to 10, or you can say the volume of hydrogen is no longer changing, or the volume of hydrogen remains the same. The next one here, this is easy to miss this question because there's no answer lines. It's because they want you to draw on the graph. And it says you're repeating the experiment and you're using the same mass of magnesium, but you're using a powder. So initially you use this big piece of magnesium ribbon, and then you take that ribbon and you crush it up into a powder. How is that going to affect the rate of your reaction? Well, you're still using the same mass of magnesium, so I'm not using more reactants. And if I'm not starting with more, I'm not going to end with more. So my line is going to end at the same place. But because a powder, smaller pieces, has a greater surface area, I'm going to get a faster rate of reaction, which means my line should be a lot steeper, and I should be drawing it on the left. All right, and make sure you're drawing it to the left, you're showing it steeper, but it levels off at exactly the same place. You're not making more just because it's faster. How will the student know the reaction is finished? Okay, this particular reaction, you're making hydrogen gas. When the reaction is taking place, you're going to see bubbles. You'll know the reaction is finished when the bubbles have stopped. Okay, so there are your questions based on rates of reactions that we did this week. The rest of the questions are from revision topic. The first one here, how do you know graphene is going to be a good conductor of electricity? All right, so you'll get this from your carousel, but you need to know that graphene has delocalized electrons. But for 3 marks, you need to explain why it's got delocalized electrons. So carbon is in group 4. It's got 4 electrons in its outer shell, and normally it forms 4 bonds. But in graphene, you can see each carbon atom here is actually only forming 3 bonds, and that means each carbon atom has 1 electron left over, and that's why it's got delocalized electrons. So you'll need to say carbon has 4 electrons in outer shell, but only forms 3 bonds. So you have delocalized electrons to carry the current. All right, so quite a detailed description. Delocalized electrons will get you 1 mark, but you'll lose out on your other 2 if you don't tell me why it's got delocalized electrons. Over here we got potassium chloride. They tell you it has a really high melting point. They want you to explain why. Okay, if it's got a high melting point, that means I need lots and lots of heat energy to pull the particles apart. If I need lots of energy to pull them apart, that must be because there's a really strong attraction holding them together. So I know that the attraction must be strong, but I need to name the specific type of attraction. And because you've got oppositely charged ions, you can see it there, K plus and Cl minus, the attraction is the electrostatic, strong electrostatic force of attraction between oppositely charged ions requires lots of energy to break. Okay, so you'd need to write all that. There's one other 6 marker here. Okay, again, if you know, and you'll get this on carousel, okay, so make sure you're doing your carousel properly. There's a few facts that you need to learn, and then this 6 marker is essentially just repeating those facts. So you're told you've got calcium and you've got chlorine, and if you react them together, you make calcium chloride. And what the question is asking you is, if you look at calcium by itself and chlorine by itself, the properties of the compound they make when they react are quite different, and they want you to explain why. So you can do this in 2 ways. You could have a separate little paragraph for calcium, chlorine and calcium chloride and go through them all individually, or you can look at the properties and you can do 1 paragraph on melting point and another paragraph on conducting electricity. So I chose to do it that way. The first paragraph I'm going to write is melting point. I can see calcium and calcium chloride both have a high melting point, so I'm going to explain why. So calcium, it's important to notice, is a metal, whereas calcium chloride is ionic. And I know this because I've got a metal and a non-metal. That's what makes it ionic. So in both cases, you've got a high melting point. So in both cases, all right, if the melting point is high, it must be because there's strong forces between those particles. And we just saw above, electrostatic forces are strong, and in a metal and an ionic compound, you've got strong electrostatic forces. So I've started here, they've got high melting points because they both have strong electrostatic forces, and therefore they require lots of energy to break those forces. Now, the attractions are slightly different. Because calcium's a metal, the electrostatic force is between positive ions and negative electrons. In an ionic compound, the electrostatic force is between positive ions and negative ions, but in both cases you've got an attraction between something positive and something negative, so I can just say strong electrostatic forces. Chlorine, you can see the melting point is low. If the melting point is low, it doesn't take much energy to pull the particles apart. That must mean the force is weak. There's only 1 type of weak force that we've learned about. Chlorine has a low melting point because the weak intermolecular forces don't require much energy to overcome. Next paragraph, I'm going to look at electricity. You can see that calcium always conducts electricity, whether it's solid or liquid. Chlorine never conducts electricity, and calcium chloride can when it's liquid, but cannot when it's solid. So I'm going to need to explain that. So calcium is a metal. It's got delocalized electrons, and therefore can conduct electricity when molten or solid. Calcium chloride is ionic. It conducts when molten because the ions can move freely. Doesn't conduct when solid, the ions cannot move freely. So what I'm seeing here is that to conduct electricity, you need charged particles that can move freely. Electrons are charged, and if they're delocalized electrons, they can always move freely, whether it's liquid or solid. With ions, ions are charged, so they are charged particles, but in a solid, the ions can't move freely, and in a liquid, they can. Chlorine, you're told, doesn't conduct electricity at all. That means it's got no free moving charged particles. Don't just say it doesn't have delocalized electrons, neither does calcium chloride, and it can still conduct electricity when molten. So no free moving charged particles, so cannot conduct electricity at all. If you don't know any of that kind of knowledge, then you're going to do your carousel quiz. You're going to learn the knowledge first, okay? And once you know that information, these 6 markers are just a case of writing it out. The answers I've given here will be kind of your exemplary 6 marker. You can still get 6 marks without giving quite as much detail, but I'd advise you to give as much information as you know.